Okay, so number 8 says a male clerk is making deliveries along a long, straight hallway. The clerk's velocity is modeled in meters per minute by the velocity. And there's your function. If the clerk starts at one end and takes 13 2/3 minutes to finish deliveries, how many meters is the clerk from the starting point when finished? So we have to remember, if we take the integral of velocity, we will end up with position. So if I take the integral from where they started at 0 minutes to 13 2/3 minutes of my velocity function, 4 pi sine of pi x divided by 5, I'm going to end up with my position. So my how many meters away am I from the starting point? Now, in your calculator, there's a few things that you have to be aware of. When we are typing this 13 2/3 in, we actually need to change that into an improper fraction or a decimal. But if we put it as a decimal, it's actually going to round it. So if I change it to an improper fraction, this is actually from 0 to 41 thirds of 4 pi sine of pi x divided by 5. And when you are typing this in on the calculator, you need to make sure that you are in radian mode. Otherwise, you will get the incorrect answer. So when you plug this in, you should approximately get 33.383 meters. Okay, number 14 says that we've got a particle moving along a straight line with acceleration modeled by a of t is equal to 2t. The velocity and position of the particle are modeled by v of t and a of t respectively. Given that v of 0 is 4 and x of 0 is 5, find x of 6. So we should kind of be thinking, well, if I have that the acceleration is 2t, then the integral of 2t is going to give me my velocity. Okay, so we kind of think, how do I get 2t? Like, what would be the opposite of that? Well, if I took v of t as t squared, if I took the derivative of this, then I would end up with 2t. So v of t is actually equal to t squared. And then I can go ahead and use my fundamental theorem of calculus to solve this problem. So if I'm going originally starting at 0 and all the way to 6, I would look at my integral from 0 to 6 of my velocity function is going to be equal to, because now when I take the integral of velocity, I'm going to end up with position. So I'm going to have x of 6 minus x of 0. And now I can just plug this information in. So I know x of 0 is 5, so I've got minus 5. And then I'd have the integral from 0 to 6 of t squared. And then the one thing that I did forget here is that our velocity original is at 4, so I'm going to need to add that to my velocity function here. So I've got plus 4 dt. Okay, so I can plug this whole thing into the calculator. And when I do, I end up with 96 is equal to x of 6 minus 5, and then add that 5 over, and I end up with 101 is equal to x of 6. Number 9 here, we've got a graph of g, where f of x is equal to the integral from 1 to x of g of t. G consists of a quarter circle and 3 line segments. Find f of -2. So if I want to find f of -2, I'm looking at from 1 to -2 of g of t dt. However, we're going to need to flip this. So this is going to become -2 to 1 g of t dt. So I'm going from -2 to +1, and now I just need to find the area underneath those curves. So this would be a quarter circle, so 1/4 pi times the radius, which is 2 squared. So that's going to equal pi. And then to 1, we're going to have a little triangle here, so that's going to be 1/2 base times height. So that'll be 1/2, my base is 1, my height is 2, So this is going to equal 1. So if I plug this stuff in, I'm going to end up with negative pi plus 1, which is the same as negative pi minus 1. Number 13 is very similar to the one that we did on the previous page. Again, we're given a velocity function, and if we're starting at one end and taking 13 2/3 minutes to finish delivery, how many meters did they go? When I'm taking the integral for this one from 0 to 13 2/3 of the velocity function, I need to put that velocity function in absolute values because distance can never be negative. So when I plug this into my calculator, again, using that same idea of being in radians and changing that number up top to be in improper fraction, when I plug this in the calculator, we should get 113.383 meters. Okay, for number 12 here, we are given values of areas bounded by the curve h prime and the x-axis on the interval from a to k. We're given that h of c is 14, and we're trying to find the minimum of h of x. So the minimum can happen where it changes from negative to positive, so that means the minimum could happen at h of c or h of k or at either endpoints. So I also need to check h of a as well. So I can use my fundamental theorem of calculus. So I can say that from a to c of my function h of c, that is going to equal h of c minus h of a. So this left-hand side here is the accumulation from a to c. So I've got 2 minus 12 is equal to 14 minus h of a. So this gives me negative 10 equal to 14 minus h of a. And if I solve for h of a, I am going to end up with 24. So h of a is equal to 24, h of c is equal to 14. So currently h of c is the minimum, but I need to check h of k. So h of k is going to equal, we know h of c is equal to 14, so then I can just add 8 to that and subtract 10. So 14 plus 8 minus 10, that's going to give me 12. So h of k is 12, and that is going to be our minimum value. Okay, similarly for number 7, we have the same graph except for we are looking for the maximum now at this point. So maximum can occur where we are changing from positive to negative or at the endpoints. So that could either happen at h of a or h of k as well. So using that same sort of process, we can look at the integral from a to c of h of c, or sorry, h of x is actually really what I should have been putting. And that's going to be equal to h of c minus h of a. So if I look from a to c, I'm going to have 2 minus 12 is equal to 14 minus h of a. So I'm going to end up with the same thing. H of a is equal to 24 again. Okay? So currently h of a being 24 is larger than h of c being 14. So currently a is our maximum. But now I need to check b. So if I look at h of b is going to be 24 plus 2, which gives me 26. And if I look at h of d, that means I'm going to take that 26, subtract 12, and then add 8 to that, which is actually going to give me 22. So this is not larger, so h of b equaling 26 is going to be my maximum. All right, number 11, we're given the graph of f prime, and the derivative of f is given, consisting of 2 line segments and a quarter circle. Given that f of 1 is 3, find f of 5. So we should be thinking we're going to have to use that accumulation function, fundamental theorem of calculus. So if I look at from 1 to 5 of f of x dx, that's going to equal f of 5 minus f of 1. And I can plug in the information that I know. So from 1 to 5, I need to find the area underneath that curve. So this area right here would be 3, and then I'm going to split this up into a quarter circle and a half, or a little triangle there. So that little triangle will be 1/2 base times height. So this is going to be 1, and then this one would be 1/4 pi r squared, which is going to equal pi. So my accumulation on the left side there is going to equal let's see, this is -3 plus 1, so that'll be -2 plus pi is equal to f of 5 we don't know, but f of 1 is 3. So then I can add that 3 over, and I end up with 1 plus pi is equal to f of 5 for your answer. Okay, lastly, we're given another graph of f prime, and we are given f of 1 is 3, and we want to find f of 2. So we have the exact same picture up above, actually, but this time we're only going from 1 to 2. So from 1 to 2 of my function, that's going to equal f of 2 minus f of 1. So from 1 to 2 here, that area is 3, but it is negative, so it's going to be -3 is equal to f of 2 minus 3. And when I add that over, I get 0 is equal to f of 2. If you still have questions, please let me know so that I can get those answered. Hope this helped. Thanks.